This is the screencast for section 9.4, example 6. In the last example, you looked at arithmetic sequences. Now we're going to look at geometric sequences. Geometric sequences are related, each term is related by a common ratio, which they call r. So instead of adding a certain number each time, they're going to multiply by a certain number each time. As you can see by this written out term by term definition of a geometric sequence, which means the explicit definition would be a sub n equals the first term times r to the n minus 1s, so one less r. The first one didn't get multiplied by r, only we started multiplying by r with the second term and on. And therefore, the recursive definition, a sub n minus 1 times r, would also only apply to terms 2 through infinity. In example 6, we are supposed to find the common ratio, the 10th term, a recursive rule for the nth term, and an explicit rule for the nth term. So let's get started. The common ratio will be the second term divided by the first term, which in this case is 2, which means the 10th term is going to be 3 times 2 to the 10 minus 1, so 9th, which is 1,536. The recursive rule for this geometric sequence would be the previous term times 2, or 2 times a sub n minus 1. The explicit rule would be start out with that first term, so in this case 3, and multiply by n minus 1 2's, so 2 to the n minus 1. Number 2, a, the common ratio, is going to be the second term over the first term, so 10 squared, or 100. The 10th term then will be 10 to the negative 3 times our common ratio to the n minus 1, or in this case 9th power. So we're really looking at 10 to the negative 3 times 10 to the 18th. If I multiply by the same base, I add the exponent, so that would be 10 to the 15th. A recursive rule for this geometric sequence would be a sub n equals the previous term times the ratio, 10 squared. And an explicit rule would be the first entry, or the first term, times 10 squared to the n minus first power, which you can simplify to 10 to the 2n minus fifth power. The now try problem number 25 asks for the same directions as the example. The common ratio in this geometric sequence is 3. The 8th term that it asks for in this case would be the first term and then times 3 to the 7th power, 4,374. A recursive rule for this geometric sequence would be the previous term times the common ratio 3. And an explicit rule would be starting with the first term and then multiplying by n minus 1 3's, or 2 times 3 to the n minus 1.